Alright, next, solving systems of equations review session. So you can solve by elimination, which is where you can add equations together to eliminate one variable, and then that allows you to solve for the one variable that's left, and then you substitute it in just like we did in the substitution method on that last step. Sometimes you need to actually multiply one or both equations by a constant first so that you can get something to cancel out. So we're going to see that in various options here. I don't know if I'll be able to rewrite this as neatly as I did the first time around, so please and thank you for your patience. Alright, clearing this out. So we got that whole instruction. So let's start one problem at a time. Notice right here, right now, we add these equations together. 3x plus negative 3x is 0x. 4y plus negative 1y is 3y. And negative 2 plus 5 is 3. Obviously, the elimination method is pretty handy, right? So we divide both sides by 3, and y equals 1. So now it's really simple to choose one of our two equations, it doesn't matter which one, to plug our 1 back in for y and solve for x. In this case, we have a 3x, we have a negative 3x. I really don't think it matters which equation we use at all, so I'll just use the top one. Plug that 1 in for the y. So we have 3x plus 4 equals negative 2, so I'm going to subtract the 4 from both sides and divide both sides by 3. And that gives me x equals negative 2. So my final answer is negative 2, comma 1. Alright, our next set of equations, if we add them together, we get 5x and negative 10y and 15. So nothing cancels out. So if we want to make something cancel out, we need to multiply by constants that will make something cancel out. For example, if I multiply my first equation entirely by a negative 3, that gives me negative 6x plus 12y equals negative 18. And then if I multiply my second equation by a positive 2, that gives me positive 6x minus 12y also equals, well, not also, because it's a positive 18, not a negative 18, right? So I multiplied by what I knew was going to get my x's to cancel out, so I could have a 0x again. So negative 3 times 2 is negative 6, positive 2 times 3 is positive 6, those are going to add up to 0, but I have to multiply everything through. Okay, so let's add these together. We get 0x, plus 0y equals 0. Well, weird, everything canceled out. What that means is these are essentially the same equation, just with different numbers, but the proportions are the same. The slopes will be the same, the equations will be the same. If you tried to graph them, they would be exactly the same line. And so this is where we have our system that is consistent but dependent. And that's where we have infinitely many solutions. So what you would normally do for a situation like this, infinite solutions, is you actually solve one of your equations out for the variable for y equals or something. So infinite solutions where y equal, basically you choose any number for x. So x is just any given value, so all the numbers. So any real number might be a better way to say that. I can't remember how our answer key took some of this stuff. I should have looked that up first. So any real numbers you can plug in, and then when you plug it in, like I would solve this. So let's move our 2x to the other side and divide everything by negative 4. I'm just going to do a little thought bubble for this. So we have 2x minus 4y equals 6. So negative 4y equals negative 2x plus 6. Divide everything by negative 4. So that gives us y equals 1/2 x minus 3/2. And we should get that same exact thing whether we solve this one or that one. Anyway, you can experiment and see if that really happens to be true. So then y would be 1/2 x minus 3y, so, or 3/2. So the reason we call this a dependent system is that y depends on what x is, but x can be anything. Then when you plug in x, it gives you a specific y value that goes with that x value that makes the system of equations true. this aside. Ooh, that is not what I meant to do. It's not going to let me group it so it doesn't go funky on me. I'm going to get rid of this little scratch work, and let's do this last problem. Alright, for this one, again, same idea. We want to multiply by something that's going to get stuff to cancel out. We could either turn the 6 and the 4 both into a 12, or we could turn the 3 and the 2 both into a 6. One of them was going to need to multiply by a negative. Let's go ahead and do the x's again. We don't have to. You can eliminate y values. It works just fine. I just happen to keep focusing on the x's. So if I get 12, or I would need a 12 and a negative 12. So if we multiply this one by 2 and multiply this one by negative 3, let's see what happens. So that will give us 12x plus 6y equals 18, and negative 12x minus 6y equals negative 36. Add those together. Oh, I got some canceling out again. Only this time it doesn't equal 0. Okay, let's compare this answer to this. So over here we got 0x plus 0y equals 0. It doesn't matter what x and y are, this will be true, because 0 times whatever x is plus 0 times whatever y is will in fact equal 0. Always, right? But this time, if we plug in any x or y value, we would get 0 times x plus 0 times y, which would equal 0, and this is saying it equals negative 18, which it can't, because 0 doesn't equal negative 18. So this is where we have no solution. The lines are parallel. They have the same slope, but they're different lines. So no solution, so that's our inconsistent option. So here we have consistent, independent. And this one is consistent but dependent. And this one's just simply inconsistent. That goes along with these things we talked about earlier, correct? All right. Oh, well, look at that. I went to my next page where I actually went through those possibilities together, and that matches up with what we're doing.